Hi everyone, I'm Saeed Abdollahi. I want to present an article entitled An LCA-LCCL Decision Making Framework for Selecting the Most Sustainable Material Transportation System in Surface Mines. Concerns about sustainable development rose around 150 years ago. Starting from the Rio Conference in 1882, the world began to follow the goals of sustainable development by defining a convergence path between its three main pillars: environment, economy, and society. In our developed method, we combined the life cycle assessment with the life cycle cost analysis. Life cycle assessment is a tool for analyzing environment effects to ultimately identify and control the impacts of the product, process, or system on the environment. Despite the increasing use of the LCA in all branches of engineering sciences, unfortunately there has not been much progress in the mining industry. According to the result of a 2020 scientific research database, only 3% of LCL-themed articles were about the mining industry. Some of these researches include Ava Oye et al. In 2009, Norgate and Haku in 2013, Fuming et al. In 2015, Erkeoğlu and Demirel in 2016, Aguirre Villegas and Benson in 2017, Beharatan et al. In 2017. Now, the open pit mines we want to study about its transportation system usually follow two methods: track shovel and crusher conveyor. Four common combinations of track shovel and crusher conveyor are presented on the next page, which is the primary basis in this study. Track shovel, fully mobile in-pit crusher conveyor, semi-mobile in-pit crusher conveyor, and fixed in-pit crusher conveyor. Each of the transportation systems listed has several economic and environmental advantages and disadvantages. Given their imbalance in terms of economic and environmental issues and considering the importance of balancing them in order to achieve the sustainable development goals, it's necessary to have a general method that can include all indicators and parameters in choosing the right transportation system. Despite all efforts listed, the mining sector lacks a comprehensive method including all essential parameters and indicators to select the best possible transportation system for an open-pit mining operation that can be implemented prior to project kickoff and pre-feasibility study and feasibility study stages. In this research, we try to address this problem using a new combined life cycle assessment, life cycle cost analysis approach. The mine we study in our research is a hypothetical and simulated mine with the Sungun copper mine in Iran. The equipment related to the selected systems was performed with the aim of determining their energy consumption in different modes and distance. Each equipment's energy consumption was calculated by using mine dataset and by referring to the equipment manufacturer's guide. In the following slides, I will briefly describe the application of life cycle assessment and life cycle cost analysis in this research. Here are the main reasons for choosing the life cycle assessment method. It provides a comprehensive understanding of environmental impacts. It determines the amount of pollutant emissions at each stage of the cycle. It also provides grants to make effective policies to reduce pollution. Based on ISO 14040, we must follow the steps below. At first, determine the purpose and scope. The identification of the least harmful transport option has the purpose to goal 1 ton of extracted material as the functional unit, and emissions from the amount of fuel consumed by the equipment were selected as system boundary. The next, life cycle inventory analysis. This stage of life cycle assessment involves gathering and quantification of input and output data that contain primary data, such as energy consumption of equipment, materials required for road construction, and secondary data including carbon monoxide, carbon dioxide, methane, nitrous oxide, nitrogen oxide, non-methane volatile organic compounds, sulfur dioxide, and ammonia emissions to water, air, and soil for the whole process. Next stage is life cycle impact assessment. To be able to obtain information for life cycle interpretation, we need to make a connection between inventory and environmental impact. There are several software for this purpose. Each software includes several evaluation methods. In this paper, we use the EMMA5 software and the recipe method. And the last one is interpreting the results. And at the continual life cycle cost analysis. There are several ways to conduct an economic study, such as life cycle cost analysis, which can cover all life costs, including initial and long-term costs, such as fuel, spare parts, maintenance, labor, replacement, that can be considered in economic evaluation. This method considers all the costs, make a correct and accurate comparison of the different scenarios, and select the most valuable and least expensive option here. It should be noted that cost data, including all costs, was selected in accordance with the life cycle assessment system boundary. Given the importance of the cost imposed on the environment, a correct understanding of environmental prices can determine the amount of economic welfare lost per kilogram of pollutants. In this study, the factors created by the Saeed Delft Research Organization, which was recently developed in the EMMA5 9 version, were used to calculate environmental prices. These costs were included as a part of annual operation costs in life cycle cost analysis. Let's go to the results section. In this phase, fully mobile input crusher conveyor does not require any road construction due to the equipment it uses, and at this stage, it does not cause any environmental damage. Instead, track shovel has the most extended road length and therefore requires more infrastructure than other scenarios. Road construction has the most significant impact on human toxicity and has little impact on other impact categories. Because fully mobile in-pit crusher conveyor consumes less fuel than other scenarios and does not require a truck fleet, it has the least impact in the category of human toxicity and climate change. On the other hand, track shovel has less effect on acidification, photochemical oxidant, and particulate matter than other scenarios. In future cost analysis using the color ranking system technique, track shovel has low capital cost. In contrast, the fully mobile in-pit crusher conveyor has a higher. Fully mobile in-pit crusher conveyor, which is considered to be one of the eco-friendly scenarios, from the economic point of view, is one of the most costly and in the first year and long term show its economic weakness. However, its long-term cost is lower than track shovel. Semi-mobile in-pit crusher conveyor is the second most costly scenario in the first year at the cost of $82 million. This indicates that this method has a higher initial purchase cost, but from the second year its costs are reduced, and in the long run it is among the lowest cost scenario and ranks first among other competitors. Finally, fully mobile in-pit crusher conveyor has a lower capital cost than semi-mobile in-pit crusher conveyor and more than track shovel, but its cost increases over time so that its long-term cost is higher than semi-mobile in-pit crusher conveyor and lower than track shovel. According to the result presented by following the two aspects of the environment and economy, it's clear that the semi-mobile in-pit crusher conveyor system is more economic. Although this system's use requires a high capital investment due to its low operating cost, after early year it becomes more cost effective than other scenarios. It also makes it more necessary to continuity production and reduce environmental pollution, labor, energy, traffic, and road construction. In the end, it should be noted that the advantage and differences of the research is the ability to perform the stability assessment of mining haulage system with incomplete or partial information. This study's main challenge was to complete and develop a dataset for analysis which has not yet been developed in the haulage system in open-pit mining. Also, considering the deficit of social criteria in sustainable mining development, it is hoped that by adding this approach along with the two studies factor, it will be used to evaluate and select the most sustainable system. Thanks for your time and attention.